Lester, Wushu Engineer. I've produced a number of videos over the years dealing with various types of reaction and response time tests, along with brief discussions of some of the traditional training approaches. Just a reminder of the difference between reaction and response times. So reaction time is the time taken for a subject to start reacting to a stimulus, while response time is the time taken for the subject to react to the stimulus and to complete a specific response action or task. For example, in a push-button test, reaction time is the time taken for the subject to become aware of the input stimulus and to start the action of pushing a button, while response time is the total time taken to react and complete pushing the button. My most recent video on this pretty broad topic was a comparison between my visual and tactile response times. Visual response times, of course, are my response times in response to visual stimulus, like for instance a light flashing or seeing something occurring, whereas my tactile response times are my response times to a tactile stimulus, so something touching me or some aspect of touch or feel. In addition, in that video, I compared my reactions and response times with other reaction and response times that have been reported in a few reasonably dependable websites and in some scientific studies. The findings were quite interesting and compelling, and I would encourage you, if you are interested, to watch that video as background to this one. The long and the short of it was that my visual responses were very fast. In fact, my shortest visual response time was shorter still than any of the visual response times that I could find documented in any reliable sources at the time. However, my tactile response times were much faster than my visual responses, my tactile responses I should say, because of course speed over response time is inaccurately phrased. So it's my tactile responses were faster than my visual responses by about a third on average. I've put up a simple graph from that video showing a comparison between these various response times for your reference. As a side note, the internet is full of information. Some of it is good information, but a lot of it is bad information. Wherever possible, I try to use the most reliable sources of information, which are published scientific studies. These are excellent sources of information because they are put through a rigorous peer review process during which most studies, not all, there are some exceptions, but most studies that present inaccurate or misleading information are identified and rooted out. As I've mentioned in previous videos, traditional systems of Kung Fu, such as my own, emphasize the development of soft points of contact with an attacker, called bridging points, and increased tactile sensitivity or feedback during combat in an effort to improve response times and reduce information leakage, or what's often called telegraphing to the attacker. The sheer scale of the superiority of my tactile response times over my visual response times demonstrated in that older video, it's a very strong argument in favor of this traditional approach to combat. I received a comment on one of my old response time videos asking for more information on how we train superior response times in traditional Kung Fu. This comment's already quite old, so my apologies for how long I've taken to get to it. The reason that it takes me so long to get to requests, aside from the fact that I'm working, like most of you out there, and trying to fit this in between work and other aspects of life, is that there's a lot of work that goes into each of my videos. I do a lot of research, I do a lot of prototyping, in many cases manufacture, builds, testing, data analysis. All of this work makes most of my videos very labor intensive. In addition, I do all of this work purely for the pleasure of presenting things that I find compelling, interesting, or that I'm passionate about. I'm not monetized. And even if I were, the size of my channel wouldn't allow it to even pay for itself, let alone anything else. I considered my viewers' request for some time and came to the conclusion that I would have to tackle it by presenting an entire series on the various aspects of reaction and response times. Because, as mentioned in my previous videos, there's a lot more to training response times than just physical training. They're both physical and mental aspects to the training required to boost your response times, past what many people may consider natural human limits. As a side note here, I realized that we would need a lot more testing equipment in order to do this topic and many other topics justice. So, we recently bit the bullet and forked over a rather large amount of money, at least a rather large amount of money for us, and purchased some rather expensive scientific testing equipment to allow us to fully explore the neural and nervous aspects of combat, training, martial arts, and combat responses. I don't want to spoil too much about this equipment here because I want to do a big reveal video of our new equipment in future. Suffice to say that this new equipment will allow us, amongst other things, to monitor brain activity in real time while performing various tests and exercises, etc. But for now, let's get back to my planned series. So I plan on presenting an introduction to 3, perhaps 4 major aspects or hypotheses of reaction and response time training. Each of these introduction videos will be presented in 2 parts. Part 1 will be a theoretical and experimental investigation, during which I will provide some theoretical background to the hypothesis and then hopefully provide sufficient experimental evidence to support this basic hypothesis. Part 2 will be a bit of a how-to training video, during which I will provide broad training tips that will hopefully help viewers to train that aspect of reaction response in their own respective systems of training. It's my hope that these videos can provide some training ideas that could help to improve your performance in your own chosen system. If this series sounds interesting to you, please show it some love in the comments section below. I don't have much of a gauge of interaction on videos because my views are typically fairly low for my videos. I don't do a lot of clickbaity, excitement-based topics. I'm more interested in the hard science behind martial arts. So if you like what you're seeing in this video, please make sure that you indicate to me in the comment section below. If there is sufficient interest, I will continue the work on the series and produce the rest of them. So, onto this video, which is part 1, a theoretical and experimental investigation into the concept of centralized movement. Now, before I go any further, I'll present the following quotes from an article entitled Introduction to Basic Wushu Qigong by Master Chen Shen Ho, who is ipso facto, or was, the head of the Chang Hong system based in Taiwan, of which my system, Chinese Martial Arts and Health Center, is a subsidiary in South Africa, and we are one of the branches of the subsidiary in South Africa in Australia. So, to get to the quote, Wushu Qigong's first basic concept, and this is Master Chen speaking, is the Dantian is center. The Dantian can be separated into upper Dantian, between the eyes, middle Dantian, solar plexus, and the lower Dantian, which is roughly 3 inches below the navel. In Wushu Qigong, the middle and the lower Dantian are places for storing qi. When considering the upper Dantian, we only discuss spirit or consciousness and not breathing. Spirit here means intention. Fist practice and qi practice both rely on the intention. We use inner body forging practice to achieve outer body development. The lower and the upper body are united with all the intention to all face ahead. Naturally, once the intention is developed, the body will naturally align to its command. When facing an opponent and only using the eyes to observe the movements, the eyes send a signal to the cerebellum, which then gets the body to respond. This is often too slow. Intention development lets us easily feel the opponent's movements, as if our hand has consciousness and can detect through touch and can directly respond. So there's a lot in these points raised here by Master Chen. In fact, too much really to cover in one video. And it's a topic that is so broad that it goes well past the scope of this video, which is reaction and response time training, and really getting there into very profound aspects of neural and nervous reprogramming of the body and the body and the brain. So it's way too vast for us to unpackage even those few quotes here in this video. But we can concentrate on the parts of those quotes that are relevant here. Firstly, the Dantian is the center, and the lower Dantian is the foundation for the mid and upper Dantian. He speaks in this article about the three main parts of the Dantian, implying that they are actually all, in fact, parts of a united system. This united, centralized system should direct all movement as steered and driven by the intention. So the Dantian, or center, is clearly involved in a trained combat response. Master Chen mentions here inner forging, or what I often call internal training, as being a key part of intention training, which in turn improves combat responses. In addition, Master Chen very accurately identifies that visual responses are often too slow to function well in fast-paced combat, and indicates that intention training allows us to expand our consciousness into our peripheral limbs, such as the hands, speeding up our responses. Now, it's very interesting that Master Chen brings this point up about visual responses, because it's completely in keeping with previous research that we've presented on this channel, and in fact other scientific research papers that have been done on this topic indicate that visual response times or visual responses lag well behind tactile or even audio responses, so responses to audio or audible signals. It's one of our training goals to make the lower Dantian the locus of all movement. In other words, all movement should be initiated from lower Dantian. All movement can then be synchronized, and effort can be coordinated and focused to maximize the available biomechanical advantage of the fighter. But why is the lower Dantian, why is this area chosen as the locus or the center? Well, there are quite a few reasons, too many to go into here in any detail. But I will briefly list some of the simpler reasons for the choice of lower Dantian as the center. Point number one, the lower Dantian is located in almost exactly the same location as the center of gravity of the human body, meaning that any action initiated here can then be easily referenced to a fighter's center of mass or center of gravity, increasing the potential for amplification of impulse and improving the stability of the associated movement. In addition, manipulating this location can manipulate the center of gravity to a certain extent. In other words, a fighter, an experienced fighter, can make their combined system, by manipulating center of gravity, can actually make their combined system appear to be either heavier or lighter to an opponent. Point number two, lower Dantian is located very close to the intestines, and thus to the enteric nervous system, which is a system of neurons embedded in the lining of the gastrointestinal system that forms part of the autonomic nervous system. While insufficient scientific study has been directed towards this aspect of martial arts, making my following statement a pure hypothesis, this close association with the autonomic nervous system could provide a more direct link with unconscious processing, perhaps enhancing neural processing speed for movements stemming from lower Dantian. And point number 3, lower Dantian is also situated roughly at the center of the pelvic cavity, which is the base or foundation of the abdominopelvic cavity. The abdominopelvic cavity can be used to produce and control internal pressure by contracting specific combinations of various muscular systems, such as the diaphragm, abdominal wall, and pelvic floor. These internal pressures can then be used to influence force production and stability. The Wushu scientists' last major study provided a good foundation to support this. That all sounds sort of reasonable in theory, but is it possible to train someone to actually initiate and control movement from lower Dantian? Well, there are plenty of anecdotal training accounts as well as training instruction sets mentioning these phenomena and supportive of this theory that stretch back centuries. However, I thought it would be a good practical investigation for this video. So the base question answered by this very small experimental investigation is, when placed under some stress, such as during a tactile response test, am I initiating movement from my lower Dantian, or is my movement simply conventional and peripheral in nature? In other words, is my brain merely sending a signal to the limb that is performing the test, bypassing lower Dantian entirely, or is lower Dantian being used to initiate the movement? As previously mentioned, the Wushu scientist and I have been studying the role that lower Dantian plays in creating and controlling intra-abdominal pressure in the bodies of trained martial artists for some time now, through our research lab Martel, in association with the University of Southern Queensland. In fact, the Wushu scientist has recently had her investigation into this phenomenon published in the European Journal of Applied Physiology, which is a very prestigious scientific journal. In this study, it was found that trained martial artists could develop greater intra-abdominal pressures and use these pressures effectively to increase the amount of force that they could produce and resist as compared to a control group of physically matched, equally active individuals. This study has formed the basis of an ongoing line of research that I am involved in personally in terms of developing electronic biofeedback equipment, test equipment, and training protocols. In the Wushu scientists' original study, intra-abdominal pressure was measured using a catheter inserted through the participant's nostril and threaded down into their abdomen. Of course, this is a necessary but a very uncomfortable procedure in order to accurately measure intra-abdominal pressure. However, for the Wushu scientists' current research project, I have developed a less intrusive piece of complementary equipment which gives an indication of internal pressure at specific locations, such as the lower and mid Dantian locations. And this is it. I don't have a cool name for it yet, and so in this video I'm just going to be calling it the belt sensor. The belt sensor incorporates a plunger which presses, actually I can show you here, a plunger which presses against a linear force sensitive resistor, which is located within this G10 fiberglass box of construction. When the front pad of the plunger is depressed by a force pushing against it, the linear force sensitive resistor reacts to that, sending a signal to a microcontroller processing unit, or interface unit, which is located in this box behind. And this in turn sends data to a computer user interface. The computer software records the data at a sampling rate of close to 20 Hertz, which is close to 20 samples per second. The system is designed so that the plunger can be placed against the abdominal wall alongside the lower or mid Dantian, and the whole sensor assembly is held in place by the belt. When pressure in the abdomen increases, the abdominal wall becomes stiffer, which pushes against the plunger, and the level of force provides an indicator of internal pressure. In much the same way, a car tire that is at full pressure feels hard when you push your fingers into the sides, while a deflated tire feels a lot softer. While the belt sensor has not yet been calibrated and checked against the catheter method to determine how much correspondence there is between its output and the catheter measurement, it can still give us an indication of the scale of pressure present in the Dantian. I thought that it would be interesting to see if it was possible to trace the origin of my movement during a tactile response test using the belt sensor. This posed a bit of a challenge. I finally decided that the best way to do this would be to use 3 pieces of measuring equipment. We would use the belt sensor to detect pressure changes in my lower Dantian. We would use our multi-timer, to measure my response time, and we would use our load cell to align the multi-timer and the belt sensor. The initial challenge facing us was that both the load cell and the belt sensor's sampling rates were only approximate and were affected by the speed and characteristics of the computer that was logging data from these devices. Approximate sampling rates would not provide the necessary precision in this case for these tests, because my tactile response times are typically less than 100 milliseconds, requiring relatively high precision and resolution to show the pertinent details. So I set up a high precision laboratory vibration generator driven by a desktop frequency generator to produce a very accurate mechanical oscillating signal that could be used to individually verify both the belt sensor and the load cell and confirm their exact sampling rates. After measuring the load cell sampling rate, it was found that the load cell data was sampled at 1,166 Hertz, or 1,166 samples per second, thus representing a resolution of close to 1 millisecond. It was found that the belt sensor data was sampled at 18 Hertz, or 18 samples per second. These exact sampling rates were used in all subsequent calculations and in plotting the data. The multi-timer is a high precision timer made by Industrial Equipment and Control, IEC, out of Melbourne, Australia. It's been designed for accurate laboratory experimental work and has a resolution of 0.1 milliseconds, so more than accurate enough and precise enough for this type of test. In order to use the load cell to time align the measuring equipment, I mounted a push button on the front of the load cell. Once the load cell and the belt sensor were activated, sampling and recording data, I would perform an Elvis Presley hip thrust against the load cell, bumping the belt sensor against it, which would create a perfectly time-aligned force peak in both data sets in order to time align the outputs of the 2 devices. I would then get ready for the test with the Wushu scientist standing behind me, outside of my visual range, so that I could not see any body language cues that would give me advanced warning that she was about to initiate a movement, which could have skewed the results. The Wushu scientist would then poke me with a stick that had a push button mounted on the tip. This push button would start the multi-timer and would also act as the tactile signal that I would have to respond to. I would then push the button mounted on the load cell to stop the multi-timer. As I pushed the button, the load cell would detect the force of my button push, thus allowing us to know exactly when the timer was stopped on the load cell data record. All recorded data would then be analyzed after the experiment was complete. Now, there was a large disparity between the 3 pieces of test equipment in terms of sampling rate and resolution. The belt sensor sampled data at 18 Hertz, the load cell sampled data at 1,166 Hertz, and the multi-timer clocked at 10 kilohertz. So when you see this data, bear this in mind, because the belt sensor data appears quite blocky and low res compared to the load cell data. This is because of the difference in sampling rate. We were thus really pushing the limits of the equipment in terms of the accuracy and precision of the comparison. However, the time alignment could be achieved with a reasonable amount of precision in context of the inherent data precision. So I am fairly confident that we could draw some sound conclusions based on these results. We performed a number of trial tests to familiarize ourselves with the test procedure before recording data for a total of 10 tests. And this is what those tests looked like. So just briefly to talk about the equipment that we're going to be using to do this set of tests. You'll notice I'm wearing the sensor here, which is going to pick up when pressure increases rapidly in my lower Dantian, or in the pelvic cavity if you like. And this is connected up to this machine, and it's going to be recording data, force data from the sensor. In addition, I've got the load cell connected up to this computer, and it's going to be recording force from that load cell. But we're actually not interested in force in this case. We're really just interested in using the load cell to pick up when I press the button, so that we can backtrack and extrapolate time data from that to time align these two devices, the sensor here and the pushing of the button there, so that we can essentially make all of the data time aligned. In addition, we're using the multi-timer to record my response times. This is not just reaction time, this is response time, because I've actually got to push the little red button that you see mounted on the load cell here. I've actually got to push that to stop the timer. To start the timer, the Wushu scientist is going to prod me with this push button mounted on the end of a stick. And as soon as I feel that tactile input, I'm going to press the button. So it's a little bit different to a simple push button test, which I would be holding in my hand ordinarily. So this is a little bit, my response times here are going to be a little bit slower, because I actually have to mobilize my whole body, essentially the beginning of a strike. So this is a larger body movement that I'm actually testing to push that button. So I don't just have it in my hand, I can't just push it with my thumb working against the grip in my hand. I've got to actually push forward, as I would do in a punch. So a bigger movement, hence slower, potentially slower response times. So we're going to take all of this data, the data from the load cell, the data from the belt sensor, and the time data, and we're going to compare all of those. And what I really want to see is what is happening down here in relation to me pushing the button. What part of my body is being activated, or is activating first in order to initiate the movement? Time alarm. After performing the tests, the data was analyzed and plotted where appropriate. And here is a table of my tactile response times for reference. My fastest tactile response in this set of tests was not as fast as in previous tests performed using a handheld push-button setup. But remember in this case that because of the setup used in this video's test, I had to push my whole arm forward in order to push the button mounted on the load cell. This incurred a time penalty due to the increased inertia associated with moving so much more of my body than in a handheld push-button test, in which I only have to move my thumb. So with that said, my responses were actually still really fast, some of the faster responses being in the order of 80 milliseconds in duration. This is a tiny fraction of a second. Expressed as a percentage, it's only 8% of a second. To put that in perspective, a supersonic bullet traveling at 350 meters per second would only have moved a distance of 28 meters, just over 2.5 tennis courts in length, in 80 milliseconds. These are very fast responses. Perhaps not Hollywood fast, but extremely fast. However, the really interesting information began to filter out once the plots from the belt sensor, the load cell, and the multi-timer had been plotted on the same set of axes. Here is an example of what the plots looked like. This happens to be a plot of my fastest or my best response time from this set of tests, test number 6, in which my response time was 82.7 milliseconds. You can clearly see from the plot that just prior to pushing the button, the belt sensor detected a rapid rise in pressure in my Dantian. Here's a close-up of this section of the plot. Because of the blocky, low-res data from the belt sensor, the starting point of the curve showing rise in Dantian pressure has to be estimated based on what the rest of the curve looks like. As such, the starting point shown on this example is only an approximation. In addition, the point at which I successfully closed the circuit in the push button does not coincide with the peak of the load cell force curve, because in actual fact that circuit would have been closed right in the beginning of that peak, because it takes very little pressure, or very little force I should say, to close the switch. The button push is thus located at the very beginning of the load cell force peak, right in the first stages of the rise in force in that peak. The rest of the force curve and the peak are just over push and are representative of the momentum of my body being transferred into the load cell as a force peak. We are working at the very limit of the resolution of the measuring equipment in the case of belt sensor, but it is very, very clear that the rise in Dantian pressure begins well in advance of the button push. The other test results and resultant plots looked similar with minor variations. All plots conclusively showed that my Dantian was actually the first part of my body to physically react to the tactile stimulus. The rise in Dantian pressure was then converted into forward movement of my arm and finger to press the button and end the test. So the tests were successful and established that trained centralized movement is possible even under the stress of a response time test. As mentioned before, we were working at the limits of the measuring technology's resolution here. So it's difficult to accurately and confidently draw any more conclusions past that one. However, that said, it certainly appeared that in most cases, the major percentage of my response time was actually taken up with physical movement, not mental processing. This was a potential result that actually surprised me. I had previously thought that it would be the other way around, that the majority of my response time would be taken up with mental processing. However, that did not appear to be the case. In some tests, it even appeared that as little as 10 to 20 milliseconds elapsed before my Dantian started to pressurize in response or in reaction to the tactile stimulus. So that time would effectively be my reaction time in those cases. Now, to put that reaction time into perspective, the supersonic bullet traveling at 350 meters per second would have only traveled 3.5 meters in 10 milliseconds, within a 10 millisecond reaction time. That's insane. Now that the basic hypothesis of centralized movement has been tentatively confirmed in the set of tests, how is it possible to train yourself to centralize all movement, as I've demonstrated? I'll present some broad training tips and suggestions in the follow-up video if there is sufficient interest in this first installment. So, as I mentioned before, show it some love in the comment section below so that I know that there is interest in me continuing with this series. I hope you enjoyed this video, and I'll see you all again next time. Cheers.